right, and here we go. Okay, so guys, 5.2 is normal distributions. We're going to be finding probabilities. So, in the section that we did on Tuesday nights, guys, we were using the standard normal distribution curve. So we were doing things like using the z-table because in the standard normal distribution curve, the mean is always going to be 0, right? And that's what we have right here. And then our standard deviations go by 1 and by 2 and by 3, or 1 standard deviation to the left and 2 to the left and 3 to the left, that kind of thing, right? So in essence, what we're going to do, guys, is we're going to figure out what happens when we have some information that is normally distributed, and we want to find those probabilities. We can transfer that information into a standard normal distribution and figure things out. So I'm going to kind of show you with the first example that I have here. It says the average speed of vehicles traveling on a stretch of highway is 67 miles an hour, with a standard deviation of 3.5 miles an hour. We pick a vehicle at random. What's the probability that that vehicle is violating the speed limit of 70 miles an hour? Assume the speeds are normally distributed and represented by the variable x. Okay, so the first thing I'm going to do here, guys, I'm going to write down a couple of things. That looks rough, so let's fix that. Okay. Do we know what the mean is or what the average speed is? 67, right? Okay, good. And do we know what our standard deviation is here? 3.5. Okay. So guys, we're going to use the formula z equals x minus mu divided by the standard deviation. And what we're going to do is they're asking us to look at a speed of what? At 70, okay? So what we're going to do is say, let's take 70, let's subtract 67, which is the mean, and we're going to divide it by 3.5, right? Okay, so guys, the first thing I'm going to do, I'm going to grab my calculator, and yes, and I'm going to turn it on. Okay, so guys, if you need a calculator, come grab one, yeah. And let's see, so we already know that 70 minus 67 is what? 3. And we're going to divide that number by, what, 3.5? And are y'all coming up with... So guys, let's go ahead and take... Remember in our z-table, the table that we were using on Tuesday night? How many decimal places... But on the table itself, for the z-values, though, for the z-values, do you remember what the z-values were? How many decimal places did we have on the z? Okay, so not for the probability, guys, but for the z itself. Let me see if I can find... So hold on, let's do it this way. Let me come back over here. While I'm doing this. Yeah, we're going to round. So when we came up with, where is it? Right here. If we're going to go to 2 decimal places, guys, what would be my z-value here? 0.86, right? Okay. So the z-value here is 0.86. Okay. I want to read the question, and it says, what is the probability that the car is violating the speed limit of 70 miles an hour? What does that mean that it's violating the speed limit of 70? Does that mean it's going faster than 70 or slower than 70? It's going faster. So in essence, what we're trying to figure out is what's the probability that our x stands for the speed, is going to be greater than 70. And what we really did here, guys, is we changed that x, we changed it really to a z value. And we're going to say, what's the probability that z is greater than 0.86, right? Because what we did is we changed that x is 70, we changed it to a z value, and that's how we got our 0.86. Guys, I want to remind you of something. When we're looking at the values here, right, using our table, do y'all agree that the table or my calculator always gives me the area which way? To the left, right? Right now, I'm trying to figure out what's the likelihood to the right? So that's going to be 0. And we came up with a 0.86. So here's 1. So a 0.86 is going to be here. We're actually looking for this area. Okay? And if this number here is a 0.86, if we use our table or if we use our calculator, we can find the area to the left. And then if we wanted to find the area to the right, what would we do? Subtract it from 1. Okay, So guys, if I were just to pull up the table, I'm going to use the table first. If you want to use the calculator, you can use the calculator. But I'm going to look at 0.86. So here we go. Let me see if I can zoom in a little bit more. There we go. See, here's 0.8, 86, 86, 86 is, let me see, this one right here, 0.8051. Okay, so we know that the area is equal to 0.8051, but that's giving me the area to the left, right? So if we want to find the area to the right, very good. So we're going to go 1 minus 0.8051. Anybody know what number you come up with? 0.1949? There we go. 0.1949, right? So what's the probability that a car is speeding or breaking the speed limit? 0.1949, or like 19.49%. But we can just leave it as decimals, okay? But does that make sense how we're able to kind of use that idea? So in essence, guys, what we're going to do is we're going to change everything that has an x value, we're going to transform it into a z, because then we can use that table or we can use the calculator, right? Tell me. This is really the z, right? Because we were looking at when x, which is my speed, was greater than 70, but we're changing those values because we don't really have a table. Like I don't have a table that says, well, what happens when the mean is 70, or I'm sorry, the mean is 67 and my standard deviation is 3.5. We're going to get the probability using that z table. So what we're going to do is we're going to transfer everything to a z format, and then we can just use that chart. Yes. Yeah, because remember, we're looking for it's violating the speed. So doesn't that mean it's greater than 70, right? So all we did is we said, look, think about it this way. We're going to sort of transform this. We're going to take this from x and 70, and we're going to transform it to a z-score. So that x is now going to become a z-score because we have, let me see if I can find it. Here we go. Because we have this z table, right? So if I can use this table to do all my problems, then in essence, really what I'm doing is I'm saying, let me take every problem that I have, let me transfer it to a z-score, so then I can find my probabilities that way, right? So look, guys, let's try another one just to make sure we kind of getting the idea here. Whoa. Yeah, we're gonna do a couple, guys. Don't worry. Okay, so let's take a look. Look at the next one here. It says monthly utility bills are normally distributed with a mean of 100 and a standard deviation of 12. A utility bill is randomly selected. Find the probability that the utility bill is less than 70. Okay, so guys, the first thing I'm going to do here, I'm going to write down our average. What is our average here? 100, okay? And our standard deviation is $12. Okay, what we're doing now is we're saying, what's the probability that my X, my utility bill, right, is going to be what? Less than 70. So what's the probability that X is going to be less than 70? X stands for my utility bill, okay? So guys, again, what I want to do is I want to see, instead of me looking at what's the probability that X is less than 70, I really want to rewrite it like this. What's the probability that Z is less than, well, whatever number that's going to be? So the first thing I'm going to do, guys, I'm going to say, look, let's find our Z-score. So remember, guys, the formula is Z equals X minus mu divided by sigma. So we set our X value. What's our X value in this case? So we're going to take 70 minus 100, and we're going to divide it by 12. So again, the first thing I'm going to do is I'm going to come back over here. Let me grab my calculator. So y'all agree that 70 minus 100 is a negative 30? Right? So I'm going to go negative 30 divided by what number? Divided by 12. Okay. And negative 2.5? Okay. So all we're saying here, guys, is that X is less than 70 is the same thing as saying Z is less than negative 2.5. Okay? Guys, remember, just a heads up again. Remember, when I'm looking at my, whether I'm using my table, guys, or using my chart, the area, if I were to come here to say, here's 0, here's negative 1, here's negative 2, here's negative 3. So don't you all agree that negative 2.5 would be, yeah, so this is going to be an unusual score, right? But y'all agree that every time I'm doing the area, guys, it's always telling me the area which way? To the left, right? And aren't we looking for the area to be what? What does that mean? Less. Isn't less smaller? Right? So I'm looking for that area.
What did you say about the chart that said,
So the chart always tells me the area to the left, right? So look, guys, the first thing I'm going to do, I'm going to bring up my table. Okay? We're looking at negative what? What's our z-value again? Anybody know? The z-value was negative what? Negative 2.5. Okay, so look, guys. Here's the negative 2.5. Do I use this one or do I go all the way to the right? All the way to the right. So what's the number that we're coming up with here? 0.0062, right? So all I'm going to do is I'm going to come back over here and say, okay, well, the probability that our light bill is less than 70 is 0.0062, right? Now, guys, for those of you who like using the calculator, right? That's not the one I wanted to do. That's the answer right there. So in essence, really what I'm doing is I'm...
So the only difference from the previous problem was that the other one was looking for the other side.
That's right. That's right. Very good. The only difference between this problem here and the one that we just did is the one before we were talking about speeding, right? So that means we're going what? Faster. We're going more than 70, right? Here we're talking about the light bill being less than $70 in this case, right? So guys, if I want to do this on my calculator, right? Remember how I would do this? I'm going to go second bars, right? And I'm going to go to the normal CDF. Very good. So we're going to go negative 99999. Okay, so guys, just to give you a heads up, why are we going negative 99999? To the left, right? So think about it this way, guys. Think about, this is my number line, right? Here's 0, negative 1, negative 2, negative 3. If I keep going that way forever, wouldn't we be going in the negative direction forever and ever? So we're saying, well, when are we going to stop? Because we're not. So let's just say negative 99999. Where are we going to stop at? And notice it's a little messy. Negative 2.5, right? So right here, we're going to type in. Guys, make sure when you're using the calculator, use the little negative button, right? Not the minus, because it'll count it wrong, or so you did something wrong. 5. And then, what, enter? Oh, I forgot my comma, sorry. That's what you were telling me, right? There we go. So let me insert my comma. There we go. And did we get the same number? There we go. Better? Yeah? Okay. So guys, let's keep going here. Let's see if we can figure out the next part of it. So look at part B. Part B says we want to find the probability that the utility bill is between what two numbers? 90 and 100. Okay, so guys, we're going to do two things here. We're trying to figure out right now what's the probability that our light bill is between 90 and, 120, not 100, right? So let me ask you a question. Do y'all agree that we're going to have to find two z-scores? One of them we're going to find it for what number? 90. Okay, so let's do this. Guys, the first thing I'm going to do, I'm going to write down my formula. Okay. And we're going to do it first for 90. So we're going to go 90 minus, we said our mean was 100. And our standard deviation was 12. Right? And so that's going to be a negative 10 over 12. And if I take my calculator, negative, I'm sorry, how much? 0.83. Is it exact or are we rounding? It's exact? Okay, cool. But look, it's not exact, but we are rounding though, right? Because it's, yeah, so good. Okay, that's good. Negative 0.83, right? Because the last number was still a 3, right? Guys, are y'all agree with me that we're going to do this again? But now we're going to plug in what number for our x? 120 minus 100 divided by 12. So that's 20 over 12. What's 20 divided by 12? Okay, very good. So guys, Anna says we came up with 1 point, and there's a whole bunch of sixes, so y'all agree with her, we're gonna round it up to 1.67? Okay, good. Boom. So this is equal to 1.67. So guys, the only thing that we're gonna do now is we're gonna say, look, let's rewrite this part. We're gonna write it using z-scores. We're gonna say that our z-value is gonna be between what two numbers? But hold on, wait, those are the x numbers. What are the z-values that we got for 90 and 120? Negative 0.83 and 1.67? Yeah, the order matters. Think about it this way. Look at the way this one is written here. That's saying your numbers your bill is going to be between how much? 90 and 120, right? Aren't we going from the smaller number to the bigger number? So now, guys, if I wanted to use my calculator on this one, right? If I were to come back here and grab my calculator and we do second bars, right? And we were to go to the normal CDF, what's the lower number that we have? And I'll give you a hint. We have it written right there. Negative 0.83. So I'm going to go negative 0.83, comma. What's the bigger number we have? 1.67, right? And I'm going to close it off and hit enter. And I'm coming up with, guys, remember how these, with our answers, we are going to go to 4 decimal places. So let me bring this back up. 0.7493. Okay. 0.7493. Okay, so guys, before I go on, let me ask you a question. If I was going to do this using my table, which value would I have to find first? The negative, right? So we would come back over here and let's say, let's find a negative 0.83. Oops. Let's find a negative 0.83. And so let me see if I can do that. Yeah. 0.8. 0.2033, right? So we would have, okay, that's 0.2033. So I'm just going to write that down somewhere so I don't forget it. Oh man, I don't got a lot of room, but I'll put 0.20, what, 33 we said? Okay, and then I would use my table to find, what would be the other value I need to find? 1.67, right? So guys, look, here's 1.6. 1.67 was, you said it right now. 9525? Okay. So then we're going to say 0.9525, and what are we going to do with those two numbers? Subtract them. And if we subtract them, guys, do we get the 0.7493? We should, right? Anybody do it? I'm just curious if anybody did it. 7492. And didn't we do a little rounding earlier? Right? So guys, but let me ask you a question. Are we coming up with it, in essence, with the same numbers? Yeah. So again, what I want to show you is, can I use the table? Yes, I can. Can I use the calculator? Yes, I can. The one that I want you to use is the one that you feel most comfortable with. Yes, sir.
After you get the answer, you have to subtract it.
No, because remember, we're finding the area, think about it this way. We're finding the area of where? In the middle. Aren't we finding the area in the middle? So we said, look, let's find the area, the way we did right now using the table, we said, let's find the area when it's smaller than negative 83. And we came up with that number. And then we said, let's find the area when it's smaller than 1.67. So didn't we count that little piece over there twice? So we're looking for the middle. We say, look, let's take this one here. And let's subtract that one there. And then we're left with on the inside, right?
So adding to this, we subtract one when they give us the smaller piece, and then they're asking for the larger part?
So think about it this way. What does the table always tell me? The area of which way? To the left. If I'm looking for the area to the right, then I'll find the area to the left and do 1 minus that to get that, right? Better? Okay. So guys, look, let's do part C. As in, can we do part C? Right? Let me ask you a question. Is this making a little bit more sense now that we've done a couple? Little bit?
The homework was kind of like that.
The homework was similar to this? Okay, so guys,
They remained the same question.
let's take a look here at this next part. And see if we can't figure it out. Come on. Don't be difficult here, man. There we go. Okay, so guys, look at part C. Part C says, find the probability that our light bill is what? Okay, wouldn't that be greater than 140? Okay, so again, guys, first thing I'm going to do, Z equals X minus mu over sigma. My X value is 140 minus, we said our mean was 100. Our standard deviation is 12. That's going to give me 40 over 12, which you said is 3.33. Okay, so again, all we're really doing here, guys, is now we're going to find the probability that Z is greater than 3.33. Guys, wouldn't this be very unusual? Because what kind of Z value do we have? A Z value that's bigger than what number? That's bigger than 3, right? So this would be very unusual. So think about it this way. When the Z value is between 2 and 3, or -2 and -3, it's unusual. When it's even bigger than 3 or smaller than -3, that's when we say it's very unusual, okay? So now look, we're going to take a look, see if we can figure this out. So this is what Fred was asking me right now. We're trying to find, because we're looking for when is the probability that Z is greater than 3.33. So guys, if you think about our normal curve here, right? I know it's not perfect, but you get the idea. Here's 0, here's 1, here's 2, here's 3. We're looking somewhere at 3.33, and we're looking for the area because it says it has to be more than that number. What area am I really looking for here then? The area to which way though? To the right. To the right. So do y'all agree that if we found the area to the left, then we could say the way I'm going to find that area is do 1 minus that? Does that make sense? Okay, so guys, 2 ways you can go about doing it. Number 1, I'm going to grab my table. I'm looking for 3 point what? 3.33. So 3.33 will be the fourth column? 0.9996. Okay? So then what we're going to do is we're going to say, okay, aren't we going to do 1 minus 0.9996 to end up with 0.0004? Does that make sense how we're able to figure that out? Because again, we're looking for the area to the right, right? Guys, let me ask you a question. If you were going to use your calculator to do this, and you're looking for the area, we know we're looking for the area to the right, right? There we go, right? So wouldn't we go, turn it on, second bars, second bars, we're going to go normal CDF. What is our lower bound going to be then? 3.33, right? And then comma, and then our upper bound, isn't that going to be the, like Myra said, 9999999, and then hit enter. And okay, so look, do you see how it's giving us this number here on the calculator? Are you all coming up with something similar on yours? Okay, so guys, if you are, just to give you a heads up, what this e to the -4 means is, I'm going to write what we have so far, 4.342. Okay, so 4.342. So I'll go like this, okay? 4.34. How it has that -4, all that means is I'm going to move my decimal point 4 spaces to the left, right? So let me ask you a question. How many numbers do I have to the left right now? 1. And if I need to move a total of 4 spaces, how many zeros would I have to add?
3.
So wouldn't we go point 1, 2, 3, and then the 4? And are we coming up with the same answer?
Yeah.
Same thing. Same thing, Jelly Bean. Right? Good, very good.
And you subtract it from one.
Right? So
So
now,
that's where I got, I don't know why I was kinda like, I don't know what I was thinking. I was thinking that we're gonna subtract from one.
no, because remember, I'm think about look at what I'm putting in as my lower bound. What am I putting in as my lower bound? The 3.33. What am I putting in as my upper bound? If I'm going all the way to the right, Fred, means I'm going all the way to infinity and beyond, right? So look what we're putting, 9, right? A whole bunch of nines, because we're going by yeah for a long time, right? All right, so guys, let's take a look-see at the next one, see if we can't figure this out here. Okay, so next problem I got here, guys, talks about Toyota Camrys. The braking distance on a wet surface is normally distributed with a mean of 149 feet, a standard deviation of 5.25 feet. Find the probability that a randomly picked Toyota Camry will have a braking distance between 140 and 149. All right, let's see if we can figure this out. So first thing I'm going to do, guys, I'm going to write what they're asking me to do. They're asking me for our braking distance to be between what two numbers? Okay, so look, that's just telling me that my x values are going to be between those two numbers. Okay, so first off, what we're going to do, we're going to write out our mean. Our mean is 149 feet, right? Our standard deviation is 5.28 feet. Okay, so guys, the first thing we're going to do, we're going to find two z-scores. Let's find the first one for 140, right? So remember what I'm going to do. I'm going to go 140 minus 149 divided by 5.28. Okay, so before you got the negative 1.7, is this what you ended up with? A negative 9 over 5.28? Okay, and then, I'm sorry, you came up with a negative, I'm sorry, how much was it? 1.70? Okay, guys, let's do the same thing again. Z is now going to be, what's the next number we're going to take? 149 minus 149 all over 5.28. Y'all coming up with 0? Guys, before I go on, I want you to think about this for a little bit. Right? Do you remember what number was always in the middle? It was always 0, right? And before we did the z-scores, when we were just looking at the standard distribution, wasn't this always our original mean, right, or our average? And so in this case, and again, this is the whole idea behind the normal distribution. The normal distribution is saying, look, whatever the average is, we're going to call that 0. And then we're just going to go by one deviation to the right and one deviation to the left, right? Okay, so guys, all we're going to do now, we're going to change this. And we're going to say, look, now not my x values, but my which values. I know, but what values are these for, though? Very good. These are my z values. Okay, and guys, again, just to give you a heads up, why are they my z values? Because I am using my z table, right? Okay, so my standard normal distribution table, right, where I have my z-scores and whatnot. Okay, so guys, let me ask you a question. If I was going to do this using my table, which would be the number that I would find first? Remember, I'm going to go, think about it this way. So look what we're looking at, guys. We already know that this number here is 0. Here's negative 1. Here's negative 2. We're looking at negative 1.70. And we're trying to find the area between that piece, right? So negative 1.70. Okay, so if I wanted to find the area in here, okay, remember guys, the z table always tells me the area which way again? To the left, right? Always to the left. Okay, so guys, if I was going to use my table, the first area I would find is, let me find the area to the left of 1.70, or negative 1.70. So if I were to come back over here and say, what is it for 1.70? Let's see, 1.70 right here, negative 0.0446. Okay, so we would come up with 0.0446, right? And then wouldn't we have to, and that would tell me this area right here, right? Okay, and then wouldn't I have to find the area for what number? But guys, if this is cutting it in half, and the whole area under that curve is 1, what would the area very good? Do y'all agree that the area, all of this here, everything that's in green, wouldn't that be 0.5? Okay, so that would be 0.5. So then now, aren't we going to take 0.5 minus 0.0446? Okay, and if we do that, guys, does anybody come up with something like oh man, I don't know, I can't think off the top of my head. 4554, thank you so much. 4554, right? Okay, and guys, if you wanted to use your calculator, how would you enter that in? Okay, so we're going to go second vars, right? Let's turn this thing on. Second vars. We're going to go to normal CDF. And what's our lower bound going to be? Negative 1.7. So we're going to go negative, negative, hold on, let's finish this real quick. Negative 1.7, and then I'll be right with you. Comma, what's my upper bound going to be? 0. And are we coming up with the same answer? There we go. Okay, so I'm sorry, somebody had a question? Yes, ma'am. The order does matter, right? How do we put which ones? 0 was what, I'm sorry? Are you talking about, okay, so my question is, are you talking about using the table or the calculator? The table. Okay, so remember, the first thing I did is I found the area this way, right? So remember, I'm finding the area, let me move my calculator real quick so we can see. Okay, that's the thing, right? But again, though, if you're comfortable using the table, that's what I want you to do, right? So think about it this way. We found the area going this way first, right? And when we found the area going that way, we came up with 0.0446, right? Then we said, let's find the area going all over here. Well, we knew that area was going to be 0.5, right? That's all of this piece here. So, Rita, if I'm trying to find this piece, I'm going to say, look, let me take 0.5, and then let me subtract that little piece right there. And that's how we came up with our 4554. Better? There you go, you got it, man. So guys, again, the main thing I want to emphasize, whichever method is the one that you like, that's the one that I want you to use, right? Let me ask you a question. Is it good to know both? Because you can always check your answer, right? You can always check your answer to make sure you're coming up with the right answers, right? And the calculator just gave us that answer at the end, right? But it's good, to me, what I like about the table, guys, hold on, I'm going to pause this real quick just so that the video is not forever and a day. Come back. Okay, so we have U.S. men ages 35 to 44 and the total cholesterol. Okay, so we're looking at men between, their cholesterol level between what two numbers right now? 220 and 255, okay? So again, guys, let's do the same thing that we did earlier. Let's find our z-score. Okay, so the first, guys, here's our mean and our standard deviation. So the first thing I'm going to do is let's go for 220. So 220 minus 205, all divided by what? 37.8? Okay, so 220 minus 205, I already know that's 15, isn't it? Okay, 0.3968. So guys, if it's 0.3968, how many numbers are we using for our z-score? 2. So if it's 0.3968, what number would we probably use? 0.40. Okay, let's do the same thing here for 255 minus 205 all over 30, 37.8. Y'all agree 1.3? Okay. So guys, look what it's telling us here. We're looking for when is the probability that somebody's cholesterol is going to be between 220 and 255. Okay. And that's saying the same thing that their z-score would be between the numbers 0.40 and 1.3. Okay, so Rita, I want to make sure that we're good, just like we did before, right? I'm going to first find the probability smaller than 40, right? I just want to make sure we're on the same page. Okay, so look, I'm going to use the table because I know you like the table, and then I'll come back and do it with the calculator. 0.40, 0.40, y'all agree 0.6554? Does that look about right? Okay, so I'm going to come back over here. So the probability that z is less than 0.40 was, I already forgot what I said, point something or another, right? 0.6554? Good, thank you. 0.6554, okay? And then I'm going to do the same thing. I'm going to find the probability that z is less than 1.3. So I'm going to come back to my table, and I'm going to go 1.3. And 1.3 looks like it's 0.9032. And then we're going to subtract those two numbers, right? We're going to take the bigger number minus the smaller number. What's the bigger number here, guys? There you go, right? Yeah. So there we go, 0.9032 minus 0.6554 is 0.2478. Okay. 0.2478. And again, guys, if I wanted to use my calculator for this, I'm just going to enter my lower and upper bounds, right? So second bars. I'm going to come down to my normal CDF. I'm going to hit enter. Our lower bound, I want to say we had a point something, 0.4? 0.40, very good. Thank you, ma'am. 0.40, comma, what, 1.3? And close it off and hit enter. And did we get the same numbers? Yeah, I'm going to move it over. Oh, come on. 2478, right? Because if we round, wouldn't we get 78? Yeah. There we go. All right, guys, I think there's a part B to this question. So let's see if we can answer part B. Okay. Okay, let's take a look here. It says, out of 350 randomly selected U.S. men in the 35 to 44 age group, about how many would you expect to have a total cholesterol greater than 260? Okay, so let's do this. Let's do the same thing. The first thing I'm going to do, guys, we're going to find our z-score. So we're going to take our number 260. We're going to subtract off, what do we say the median? 205? Thank you. 205 divided by, it was like 30 something? 37.8, okay. Guys, I'm going to give you a minute. I want you all to do that for me just so I don't have to grab the calculator again. 1.5? That's two decimal places, like 1.49 and change? Is that what it was? Yeah, so 1.5? Okay. So guys, remember what we're looking for here. We're saying what's the probability that their cholesterol is going to be greater than what, 260? Okay, so isn't that the same thing as saying that the z-score is going to be greater than, what do we say? 1.5? Right now? Yeah, it should be 2.
So then it would be 46.
Okay, 46. Okay, yeah. That's all I was asking. So guys, remember the z-score, your z values have to be two decimal places, right? Because of using my table, right? Finding 1.46 and finding 1.5 would give me actually different numbers, right? Okay, so guys, think about it this way. Look at what we're trying to figure out here. I want you to sort of think about the picture. Okay, here's 0. Here is 1.46. We're finding the probability to the right. We're looking for this area. Couldn't we say, let's find the area which way? To the left, and then do what, 1 minus? Okay, so guys, I'm just going to grab my table because I know it's right here. 1.46, here we go. 1.46 is what number? 0.9279? Does that look about right to y'all? What do you think? Yeah, 0.9279, okay. So we know the area to the right, or I'm sorry, to the left is 0.92, what did I say, 79? Okay, so we want to find the area to the left. Wouldn't we do 1 minus 0.9279? Okay, so guys, if you take your calculator and do 1 minus that, 1 minus 0.9279, and are you coming up with 0.0721? Okay, so we're not quite done yet. We're going to figure out what this means. Okay, so we came up with, I'm sorry, 0.0, what was it, 721? Okay, now guys, look what the question says. The question says, how many people are we looking at here? We're looking at 350 of them, okay? So out of 350, what percent of them would have a cholesterol greater than 260? About 0.0721 of them. So what I'm going to do now, guys, I'm just going to take this number and we're going to multiply it by 350. Okay, so if I take that number times 350, now guys, remember what we're looking at here. This is the number of people. So the first thing I would write down is I'd say that's 25.235, right? So I'm going to say, well, that's 25.235. About, that's equals, but about how many people is that? 25, right? That's about 25 people, right? Because you can't have 0.32 of a person, right? And there we go. All right. So, guys, let me pause this dealio right here.